What are the disadvantages of multi-driver headphones? And this question comes from Wit in Thailand. Why do high-end custom IEM headphones, in-ear monitor headphones, have so many drivers? What is the advantage and the disadvantage of so many drivers in a headphone? How do they make the large value inductors for low-pass filters so small and still have low resistance? Okay, well, a couple of questions going on there. First off, I do not claim to be a headphone expert, but I can tell you a few things. Let's get to the inductors. So think about hearing aids. Hearing aids are miracles. Have you ever seen, some of them are just as tiny as they could possibly be. And they use surface mount inductors. They use surface mount parts and these little tiny microscopic bits and batteries that go into these things. Those are miracles of engineering. I have no idea how they do it. I know they do it, and it certainly can and is being done. So compared to a hearing aid, an in-ear monitor is, it's a boulder compared to a speck of rice size. But so inductors all depend on the number of turns. Okay, so if you need 20 turns or 30 turns or 100 turns, whatever you need for that inductor, all inductors are the same in that the number of turns are determining the inductance. And so, but the amount of current going through there determines the gauge of the wire. So if we don't have much current going through, as we don't in a headphone or in a hearing aid, you can have the most microscopic hair of wire that's wound around a very tiny little core and get the same filter results as you would for one of our big Ballons that uses solid core 12 gauge wire, and that thing's a moose. And so, because we're running a lot of current through it, and impedance and the DC resistance of the wire matters a great deal to us. So that's how they get away with that. But to your question about the drivers, well, in general, drivers need to be separated because there are very few types of drivers that can handle all frequencies at the same time. A planar driver can do a pretty good job of it, and because they're small, you don't have the problem of the high frequency creep going up and down, and because they don't have to get very loud, the Doppler, which is as a slow moving diaphragm or membrane goes in and out, the more it does, the more Doppler distortion, where it's, and because the high frequencies are running onto this same big panel on a bigger speaker, as you move a lot of surface area to get loud sound, you're increasing the amount of Doppler distortion that the higher frequencies get moved back and forth. Because remember, a 20 kilohertz signal or a 10 kilohertz signal, they're only quarters of an inch. And if you're moving the diaphragm quarters of an inch, that's like taking a tweeter and going like this with it at those high frequencies. You will hear that. But in a headphone where you don't have to move, only very little movement is going to cause a lot of sound because it's right on your ears, then that Doppler is reduced. So you can get away with a lot in a headphone that you can't in a speaker. But nonetheless, plenty of manufacturers still want to divide the frequencies up so that you have a dedicated tweeter, mid-range, and a woofer. But a little worried about headphones. My friend Richard Murrison, who is the owner of Bit Perfect, and he works very closely with us. He and his son Tim are helping design the Octave software program that we have coming up, our music management program. And Richard was talking to me about, he said, do you know why it sounds like music is in your head when you're listening to headphones? I thought, well, no, I don't. It's still the same two ears. So when I'm listening right now, and if I have a stereo playing, it doesn't sound like it's in my head. The center channel sounds like it's in the center. That's an illusion I can buy, but it's not in my head, it's outside. I can tell it's outside. But when I listen to headphones, using those same two ears, listening to the same music that I would on a stereo system, it doesn't sound like it's outside. It sounds like it's in the middle of my head. I hear this presentation inside my head. So why is that? And Richard said, a couple of guys have done some really excellent work. In fact, one man has done a lot of work on trying to figure that out. And what he's discovered is that it's an artifact of the head movement. Our brains are very sensitive to phase and to amplitude and directionality. And when we move our heads, even a little bit, sitting in front of you right now or in front of a stereo system, our head, when we do that, our ears and brain can detect those small changes to where it's just slightly louder here, it's just slightly louder here, the phase angles are changing as I move my head, and my brain says, okay, yeah, I'm buying that. It's external to me. And I know that because, I'm not stuck like this. When I actually move my head, the sound changes. So I know the sound is external. But when I hear something and I move my head and the sound doesn't change, well, the only way that could possibly make sense to my brain is that it has to be happening inside of my head. And that's the thought process that goes by. And that's one of the reasons that headphones are forever flawed compared to loudspeakers. We can never create, unless we have a way of monitoring our head movement relative to what we're hearing inside a headphone. Now, if you can do that, you got problem solved. So just imagine we have magic headphones. We put them on, the headphones register all the movements of our head, and we can then hear, we could fake it and think that it's happening outside, but we don't do that. And so that's the reason that happens. But anyway, interesting subject. So that's, again, I'm not an expert on headphones. I'll give you what I got, and that's basically it. All right, we'll talk to you tomorrow. Thank you. Bye.